This is one of my favorite principal components examples, and it involves data about FIFA soccer players. Now, the data can be found on the website, and if you just look at the column names of this data, we have information about players. I have their name, age, a picture, it's a URL to a picture, nationality, the flag, overall, which is a score between 0 and 100, which is designed to measure the overall ability of an individual. Potential, I'm actually not sure what that is. Club logo. And then after special here, where you see the number 13, starting here, you have scores from 0 to 100, measuring different player abilities. So how well can they accelerate, be aggressive, finish, mark, make interceptions, what's their stamina like. We have some attributes about goalkeeping. And then the last variable in this data set is called position. So it's what position, and this was actually derived from their preferred position. These variables within the yellow boxes here will actually be used in our principal components analysis. So I'm not going to use, obviously, the player's name or picture, but all of these attributes measuring some ability. Now, we just want to explore that data first. You might look at a summary of those columns. This would give you similar to a proc univariate output. And one of the things you might notice is that the maximum value is always less than 100. So nobody gets to be perfect here. And the minimum is generally better than 0, although sometimes it's 1. This might be me, not a very good goalkeeper. And another part of exploring the data that we should probably always do when we're using principal components is to look at the correlation matrix. And when we look at this correlation matrix, there's a pattern that jumps right out at us. And it's this little cross here. And that has to do with those goalkeeping abilities. So those goalkeeping abilities are highly correlated with each other, having strong positive correlation, but negatively correlated with everything else. So goalkeepers don't tend to be good finishers or passers. That's not what they're trained to do. And similar for field players, don't tend to be great goalkeepers. We also see a high degree of correlation outside of those. So there's a lot of numbers here, like marking and slide tackling, that are very strongly correlated. So anytime you have a high degree of correlation, it's a great place to use principal components. So we can compute the principal components just with PR comp. You notice I use the scale equals true. I leave it off. I leave off the scale option. So I'm using covariance PCA. Why? Because all those variables are on a scale from 0 to 100. So there's no need to standardize. Now I could always check out the correlation version if I want to. We'll leave that as an exercise here. If I use the summary function, I get the importance of the components, and I can see with just 2 components, I can explain like 76% of the variance in this data. That's pretty remarkable. So now that I know that I'll have a good projection in 2 dimensions, let's actually plot that projection. And of course, I see this beautiful picture with this group out to the side. If I want to know what that group is, the best way to do that would be to examine the loadings. Of course, what's different about this group? Well, their first principal component scores are significantly different from the other group. So when we look at the loadings, I really want to pay attention to this first principal component. And as I look down these scores, what should jump out at you is the sign differences. So almost every ability here is negatively loaded on PC1 except for the goalkeeping abilities. So if you have a higher score on PC1, you're going to have a better goalkeeping abilities. Well, maybe that means that group there is the goalkeepers, and they are. If I color the projection according to the player's position, I can clearly see the group over here to the right are the goalkeepers. The forwards are up at the top, defenders are down at the bottom, and then it makes sense that the midfielders are sandwiched between, right? Because midfielders will share some of the skills of forwards and defenders, and have some of their own skills, unique skill sets. Of course, if we make it a biplot, we can understand just what those skill sets are. Now, I'm using a function called autoplot to draw this, and it allows me to move the labels of these arrows off the lines. But these goalkeeping arrows, there are 5 of them, and they are almost completely pointing in the same direction. So goalkeeper kicking, handling, reflexes, diving, positioning are all pointing in this direction, even though the labels are off that direction. Now up top here, I see I have finishing skills, volleys, penalty kicks, agility, positioning. These are all things I expect from forwards. Good vision, good balance, sprinting. Down at the bottom, interceptions, slide tackling, standing tackling, and marking. Aggression, things I definitely expect from defenders. And in the midfield, you're gonna have some crossing, ball control, free kicks, composure, both kinds of passing, short and long passing here. There's long passing, yeah, and stamina. Another thing you would expect from midfielders, especially those center mids, which tend to also show up on defense. Now, the positioning variable here, the position variable is not perfect. I think you can see that, especially up here. Some of these almost clearly look like forwards. They might be wings. They might prefer to play the wing positions, which would be marked here as midfielder, but they might often get put in as forwards. We can also color this by overall ability. So this is that overall variable, and you can see it lines up rather well, where the further you get from the mean, the stronger of a player you are. And the goalkeeper is kind of as far as you get in this direction, the better you are. Now, it might be interesting to label some of the outliers here. And indeed, we see some names that are probably familiar to people who aren't even avid soccer fans. You see Messi up here, Bale, Pogba, Vidal, Milner, Maleta. These are kind of overlapping. If you examine the PDF document on the website, you might be able to see some of those names more clearly, and you could label some more if you'd like. Now we could also color this by wage. Here I have the wage of the players, and you notice it's not nearly as clear of a correlation as it was for overall ability, right? For overall ability, I go from dark to light on the outside, and that looks very clear. Here, I certainly go from dark to light. You can see that the wages increase as the abilities increase, but it's not as clear. And that could be differences between clubs, but there are some things you might be interesting to explore here. In particular, one of the things that stood out to me just by poking around at some of these names might be racial discrimination. I've heard anecdotally complaints about the European FIFA leagues for racial discrimination in wages. This might be a good data set and a good method to explore that. Anyway, I have some lab exercises here. The first is to use a logistic regression to try to differentiate between midfielders and forwards with just 2 principal components as input. And create one model using correlation PCA and one using covariance PCA, and see which model is better. Similarly, use a linear regression to predict the variable overall using just 2 principal components and compare those results. And in both of these exercises, you could use functions of those components, like polynomial terms, if you'd like to, just to see what kind of predictions you can get.